Welcome to the 3ds Max Basic Modeling online class. I'm your instructor, Li Ruijing. In this lesson, we'll focus on adding small details to the windmill cabin model. For example, the U-shaped decorative bell and the stairs. Teacher, after finishing these models, will the project be considered complete? No, we still need to organize the models according to the project specifications before it's fully completed. Once that's done, the entire project will be complete. Let's begin the process. Open Max, press F to enter the front view. In the standard primitives, find the tube. In the front view, draw out a tube to create the U-shaped decoration. When creating the tube, you need to click the mouse 3 times. The first click creates the outer radius. The second click sets the inner radius. The third click defines the height. This time, we can skip the mouse click and rotate the viewport. Now, you can see the height of the tube in the orthographic view. Adjust it to the appropriate height, then click the mouse to confirm. The shape of the entire tube is now set. Once confirmed, turn off the height segments. Set the sides to 16. Move it to the appropriate position. Go to the Modify panel. You can make further adjustments to the height here. Check if it matches the concept art. Make minor adjustments to the radius. Once confirmed, right-click and convert to Editable Poly. Select the face level. Select all faces in the lower half. Make sure to select all the faces in the lower half, then press Delete to remove them. Next, go to the edge level. Select these 2 edges at the bottom. Hold Shift and drag down along the Z-axis. This will copy the new faces. Then, find the cap option in the edge editing section. Close off the edges. After this, press F to return to the front view. The inner circle here is slightly too large. Select all the points of the inner circle and scale them down. When scaling, pay attention to where my mouse is placed on the coordinate axis. If we place the mouse between 2 axes, you'll see the scaling axis icon as a triangle with gaps on all 3 sides. This indicates that only 2 axes are selected. However, if I place the mouse in the center of the entire coordinate axis, clicking it will turn the triangle into a closed shape. This means I've selected all 3 axes, X, Y, and Z. Currently, we're only adjusting the selected points' vertical and horizontal shapes. So, we only need to scale along the X and Y axes in this 2D front view. Then, slightly adjust the Y axis. OK, after scaling, select the points at the bottom. Compress the Y-axis significantly. Straighten these points back to being straight. Now, the shape of the inner circle is adjusted using scaling. After adjustment, select the point at the bottom left corner. Click the small window for chamfer. If the face distribution is irregular, set the segments to 0 to fix it. After chamfering, click the checkmark to confirm. Then, hold Ctrl and additively select the diagonal points around this chamfered face. Because these areas have been cut into polygons, use Ctrl plus Shift plus E to create edges connecting them. This completes the U-shaped ornament. Rotate it. There is an identical ornament on the other side of the roof beam. Therefore, we first need to adjust the pivot point of the U-shaped ornament. Select this U-shaped ornament, then, enable Effect Pivot Only, and click the Align button. Next, select the main structure of the house. Align the X, Y, and Z axes of the U-shaped ornament to the coordinate axis of the house's main structure. Click OK. Now we can mirror it along the Y-axis using the Instance option. After finishing that, let's create the beam above the door. Find the box in Standard Primitives. Check the Auto Grid option. Drag in the front viewport to create the shape of the beam. While dragging, you can simultaneously rotate the viewport. This allows you to see the height of the box. Once confirmed, convert it to an editable poly. Go to the vertex sub-object level. Adjust the points at the back, moving them inward towards the house. Then, select the faces that are hidden inside the main structure. Delete them. Select the front faces and scale them slightly, because the wooden strip in the concept art is thicker at the front. After completion, reset the model's X-axis position to 0. Then select the top faces, slightly adjust their thickness. Box select the longest edges from this ring. Right-click and find Connect. Connect 2 new edge loops and adjust their spacing. And slide them to the position near the door edge. Then, box select this newly connected loop of faces. Change the bevel mode to local normal. Adjust the bevel height and the outline amount. This creates the metal ring on the wooden strip. It looks a bit too thin. You can box select half of the points. Move them along the Y-axis. The entire model slightly intersects with the roof. Move the entire model up a bit along the Z-axis. Rotate the view to check, and the wooden beam on the door is now complete. Now, let's create the bell. Find the cylinder in standard primitives. Disable AutoGrid. Drag out a cylinder, roughly the size of the bell. Move it to the position corresponding to the bell in the concept art. Reset the X-axis to 0, press T to switch to the top view. Align it with the position of the metal ring that holds the bell. There's no need to change the height segments. Directly right-click and convert to editable poly. Then, select the top face and scale it. Scale it down to a very small circle. Right-click, find Extrude, and extrude a height. This will be the string for hanging the bell. Then adjust the height so it just intersects inside the metal ring. Then, select and delete the faces hidden inside the metal ring. Now, double-click to loop select the other horizontal edge loops. Adjust the bell's shape by scaling these loops. The bottommost loop of edges cannot be selected by double-clicking because its base is a single polygon. Select the polygon at the bottom, right-click, and choose Chamfer. Set the extrusion height to 0 to create a flat plane. Right-click again and collapse this plane into a single point. Now, go back to the edge sub-object level. Double-click to select the loop of edges at the very bottom of the bell. Scale it uniformly. Next, adjust these loops on the bell. This will make its shape closer to that of a bell. After shaping it, press F3 for wireframe display. Box select all the vertices of the entire bell part. Now, the entire bell is a bit too large. We need to scale it down uniformly. You can also scale it to be longer. Compare it with the concept art and adjust the overall size. Once adjusted, box select all the models. Press M to open the material editor, assign a gray material, and apply a black wireframe color. Next, let's create the stairs. Find the box in standard primitives. Drag out a box at the doorway location. The height of the box should match the first step's height in the concept art. After creating the model, move the entire model inward slightly. Press Alternate plus Q to isolate the box. Right-click and convert to editable poly. Select the faces that are hidden inside the house. As you can see, the faces I selected are indeed the invisible ones. Press Delete to remove them. OK, now go to the edge level. Select these vertical loop edges. Find Connect. Connect 3 edge loops. Click OK. Go to the polygon level, hold Ctrl and select these 3 back faces. In the Edit Polygons rollout, find the small window for Extrude. Extrude a height. This height will be the height of the second step. After adjusting the height, click the checkmark to confirm. Then select the next 2 faces. Find Extrude. It will use the height value from the previous operation. This will be our third step. Then select the last face, extrude it to the same height, click the checkmark to confirm. This completes the 4-step staircase. Press Alternate plus Q to isolate it. The newly extruded faces at the back are not visible. Delete them. These edges on the side are all on the same plane. They lack proper structure, so press L to switch to the left view. Select all these unstructured edges. Rotate the view. Check if the edges on the back are also selected. Once confirmed, press Ctrl plus Backspace to remove the edges and their vertices. Now, this side has been reduced to a single polygon. Switch to the left view. Select these points on the staircase. Simply press Ctrl plus Shift plus E to connect them. OK, assign a grey material to this staircase as well, and a black wireframe color. Rotate the entire model to match the viewpoint of the concept art. Finally, let's take one more check. The top of this post isn't intersecting with the roof yet. So, select its edges and move it upward. It's protruding a bit here. Select the edges and move it inward. After moving it, we can select the faces hidden inside the roof and delete them. Press F3 for wireframe display. You can see the wooden post intersects too deeply with the stone base. These are the invisible parts. Go to the vertex level and box select these points. Move the entire selection upward, just enough so it intersects slightly with the stone base. Press F3 to exit wireframe display. Adjust its position a bit more. OK, that's good. Now, let's rotate the view. Look at this area at the back. The other side of the house is missing a window. So, select the existing window. First, adjust its pivot point. Enable Effect Pivot Only. Reset the X, Y, and Z values to 0. After resetting, look at the coordinate axes in Effect Pivot Only mode. Because this window was rotated to fit the wall surface, in the Effect Pivot Only mode, the wireframe coordinate axes that appear are not fully aligned with the model's own coordinate axes. This creates a problem. To fix it, find the Reset Transform utility in the 6th toolbar. Click Reset Selected. Then, go to the Modify panel. You'll see a Reset X-Form modifier has been added. Right-click and convert to Editable Poly. Now enable Effect Pivot Only again and check. Now we can see that the pivot's axes are perfectly aligned with the model's local axes. Mirroring will work correctly in this state. Now we can instance mirror it to the other side using the X-axis. After doing this, let's rotate the view and check it again. Switch to the concept art's viewpoint. The checking is complete. This windmill is basically finished. Now, let's optimize the model according to the project specifications. First rule, the project units are unified to meters. We set this at the very beginning of the project. The units have already been configured. Second rule, the model's triangle count must be under 1,800. Click the plus sign in the viewport's top left corner to open viewport configuration. Go to the Statistics tab, check Triangle Count and Total Plus Selection, then click OK. Press 7 to toggle the statistics overlay in the viewport. You can see the selected model has over 1,800 triangles. This already exceeds the project's specified limit, so now we need to optimize the model as needed. Delete some invisible faces. First, look at this pillar. The faces at its bottom can be deleted. Similarly, the faces at the bottom of the main house structure can also be deleted. Rotate the view and inspect again. Isolate the window. Rotate to look at its back. This back face is the one attached to the wall. It was already deleted when we initially created the window model. Exit isolation. Check other areas. Isolate the roof section above the door with Alternate plus Q. These two faces are intersecting inside the wooden slats. You can delete them. This bell is a very small model. Currently, it has too many faces. We can reduce its face count. Watch my operation. Select every other edge in the loop, holding Ctrl to add to the selection. With the loop selected, click the ring button. Right-click and choose Collapse. See, the circular edges of the bell, originally a cylinder shape, have been simplified. Also, the string at the top of the bell is very thin. It doesn't need a cylinder with so many segments. So we can continue, skipping some edges. And select again. After selecting, click Ring again. Hold Alternate. Deselect the edges on the lower part of the bell. After confirming only the edges on the bell's string are selected, right-click and collapse. Now, as you can see, the bell's shape hasn't changed, only the face count on the string is reduced. With this optimization, box select the model. You can see the selected model's current triangle count is just over 1,700. We've reduced over 100 faces. This meets the project specification. But let's continue deleting some faces that should be removed. Remember when we made the chimney, the faces hidden inside the roof weren't deleted. Isolate the chimney. Now, delete these faces. Isolate and check the roof. This face hidden inside the beam can be deleted. Rotate the view again. Basically, all the invisible faces have been deleted by us. Box select all models again. You can see the polygon count is now just over 1,600. Good, the second project specification is now met. Let's look at the third rule. The model's pivot point should be at the center of its bottom. Reset the X, Y, Z axes to 0. Fourth rule, all models must be merged into a single object and named. Rules 3 and 4 can be accomplished together. Now, box select all models, right-click and convert to editable poly. Select the main house structure created first. In the Edit Geometry rollout, find the Attach button. Click the small box next to it to open the Attach list. In the Attach list, hold Shift to select all items from top to bottom. Then click the Attach button in that dialog. This attaches all the windmill cabin models together. After attaching, you can see the model's X, Y, and Z coordinates are indeed at the origin. This is because when we started the first main model, we developed the good habit of zeroing the X, Y, and Z coordinates. Now, go to the Utilities panel. Find Reset Transform and click Reset Selected. Then right-click and convert to Editable Poly again. In the Modify panel, change the name to Windmill Cabin. After this, let's check the fifth project specification. Model faces must only be triangles or quads. This specification is common for low poly modeling projects. During low poly modeling, develop the habit of spotting n-gons and adding edges to fix them. Rotate to check. The current model has no n-gons. Thus, we have optimized the model according to the specifications. Here are two modeling insights for you. From the initial model to the final version, the methods can vary. Many commands can achieve the final result when modeling. So, as long as the final goal is clear, all roads lead to Rome. Now, for the second point, let's discuss where the Rome is in low poly modeling. The most important aspects of modeling are shape accuracy and aesthetic appeal. No matter which method is used to create the model, we must adhere to certain aesthetic principles. Maintain control over the shape's accuracy and visual appeal. These are our two modeling insights. In this project, we understood the principles of low poly modeling. We further improved our familiarity with the software. We learned how to combine models. Alright, the low poly modeling for the windmill cabin scene concludes here. See you next time, students.